Alright, here's a demo of this SDC book. I think it's chapter 5 or section 5.1. It tells you about this crank slider here, where we have a 75 millimeter crank, 200 millimeter connecting rod. They're going to show it at 2000 RPM. I think we could do that. I think I'm going to go 20 RPM instead. You'll see why. But anyway, they start out by showing you these results, and I guess maybe we could try to go through these 2000. The only problem is when we get to that. Let's just see. Okay, so they have the results, and they can show the velocity of this piece right here of this piston. So I'll just go through it here. Hopefully it won't be a very long video, but we'll see what happens. All right, so I'll put this onto the other side of my screen here and show you piece by step. And this is in case you're not familiar. So I'll start with a new part. I'm a little bit of a stickler for this. I really don't like the default background. So go to this beach ball on a blanket up the top and just go white. Make sure that you're in the right units to start with. You have to do this almost every time. You could set this default in your settings or something, but I just always go down to here and make it millimeters. So I'm going to go on the front page and start a sketch. So in case you forgot how to do that, I should first mention. Okay, so I touch front plane, and I can't just left click, right click, I guess. And there's a new sketch. Now I've created a sketch in this plane. I'm going to go up to this slot, straight slot, click here, come off, and I'll make it straight here, and I'll go to dimensions, and I'll make this 75 millimeters. We'll use their width is 20, okay, and I don't like how they do this, so I'm going to change it. I'm going to put some circles in here for the pins, and I'm just eyeballing it. I think it would look better if you had 5 millimeter pins. They're good enough. Okay, so we'll use 5 millimeter pins everywhere, and we will create now this part. They didn't. I think they make some cuts here in the next pages. Yeah, okay, so they make some cuts in the next pages. So we'll just leave this here, and they decide to make their width 10 millimeters. So we will go up to here to extrude. I've selected the sketch and extrude, and it defaults to 10 millimeters, so that's good. I like to keep everything in like having the plane as be the center. So instead of blind, we'll go mid plane. All right. So now this thing is arranged so that the origin is right there at the intersection of the front plane, the top plane, and the right plane. And save this somewhere. I will put this underneath my Dynamics SolidWorks tutorials. Make a folder for it because we have a bunch of parts and we want to keep it organized. So this is the SDC crank slider tutorial from Dynamics Lab, or they call it something like that. SolidWorks. That's good enough. I'm just going to call it crank. We'll make another part, come up to here, another part, and we're going to basically do the same thing once again. Now we're going to go on the front plane again and make another link. We'll do the slot thing again. Boom to boom. And length of it is, of course, you could always slow this down or stop it, rewind it. Once again, this is going to be 20. Boom. So, and then might as well make our little circles here. Of course, this is different from what's in the book's tutorial, but that's fine. It's not going to hurt us. I think it'll make life a lot easier. So 5 and 5, boom. And I think on the next page, so I'm on page 102 and I'm looking at this, they went to mid-plane and they decided to make this 20, I believe. Yeah. Oh yeah. Okay. So 20. Okay. So anyway, I'm not out of the sketch yet. Boom. And then go to extrude, and it remembers that we were mid-plane, and now we want to go 20. I just click one thing up, so it's 20 millimeters wide. Boom. And now we want to change the view. And well, we could we could do this in different ways, but I'm going to click onto here, and I'm going to add a sketch onto the top. And what we'll do, I'm trying to see. Oh, I see. Okay, they did this in one step. This is a little weird for them to do this in one step, I think, but that's all right. I'm going to take a center line. I always find that to be like a little bit easier to get where I want to go. Right there. Boom. And I think they're being a little weird in the way they put things on here. I'm going to make a line like this right here and make that, click that, hold down Control, and I will make that the midpoint. And this line right here, I'll make that, well, they decided it was 100 off of that. Okay. I'll also make this width of this is 10. Right, so they're being a little weird in the way they're making things. We're making cut planes. We're making a cut feature right now. So I've taken a little bit of a liberty right there. Like this distance doesn't matter as long as it's longer than that right there. So if you want to make this, you can make this anything you want. You can just leave it blue if you want. I'm gonna go 120 just to make sure that we cut there, right? So all of that's going to be cut. They've decided, it appears to me, that they're going to do a similar thing, except coming on this side, and they've made another line like that. Now, all right, how would I want to do this? I'm going to make another center line, and I'm going to do the same thing that I did over before. I'm going to make it those two things midpoint and make this 10 again. So that's 10, and it already was. That's good news. This they've dimensioned as 90. Right, so you can see that there's a little bit left in between here. And what we're going to do is we're going to make two rectangles. We could do that in a couple ways. I'm going to do it this way. I'm going to come up to here and I'm going to make a corner rectangle. Pull it down and come up to here, to down over there, and I'm going to do it again. Down over here. Boom. And the width of this and the length of this don't really matter, but as a good principle is to never leave a sketch blue, fully define it. So let's be good stewards. And this one right here, you can make it, I think 100 will end up right in the wrong spot. Yeah, we would rather have that be 110. And then you could, if another thing you could do is just I selected this, hit Control, and then make them collinear. There you go. So we're fully defined. So when we get out of this, we can hit the cut with that sketch, and we're going to go through all to everything. We could so just through all both makes it easier, so that you end up with this right here. All right, so we're left with this part. I know that was pretty quick, but I want to make the video short, so you can always pause and go back, hopefully. And this is Conrad. We love you, Conrad. Oh, yes, we do. See, it was a Bye Bye Birdie thing. And they had slide through all, and let's see, so on page 103, we've saved this. Now we're going to make a piston. They do a weird thing. It looks unnecessary to me, but we'll do something similar for the piston. Once again, make everything white, make it millimeters, and I guess I'll go in the front plane. I don't mind. And from the origin, I'm going to use a center line again. Boom to here. Now make a line like this, and I'm going to go down to here, past where they went. And all right, so I just kind of sketched out a thing, and now I will make it the same dimensions as theirs. They have this as 50, so everything scales to that, and then make it to 20, scale, boom, to there. And then they made this 5 millimeters. That's fine by me, and another 5 millimeters here. And then this will make from here to there, we'll make that 10 millimeters, and we're fully defined. Okay, and I think we're going to revolve this. So this says somewhere. Revolve. Yeah, they're going to revolve. So I have the sketch selected and go resolve base right there. Boom. And they already recognized that that was the line to do it about. So you get the preview, and that should be fine. Boom. And now we want to make a circle, carve out a circle. So we hit another sketch. We'll do it on the front plane. I'll right click for it, sketch, boom. And I'm going to make that circle. For this, they decided to make it 10. I don't know, might as well make, I was thinking about making it 5 so it could match my other thing. There's no reason to make it 10, make it 5. Looks pretty small, doesn't it? Boom. Anyway, that's going to be the hole about which this thing goes back and forth. Okay, and now we'll, with that sketch selected, we'll get the cut, and then we'll go through all both, and it should make, whoop, well, through all both directions, through all both. There you go. I don't know why I didn't do it with the default button. I clicked it again. There you go. All right, so now we have, this is the thing we want. Let's save it, and that's just the piston. Now, a lot of information, 13 minutes into this. All right, so now we want to create a an assembly, and so now that's on page 104, and we want to start a new assembly. So new assembly, boom. And I'm gonna break with this part of the thing. I'm not gonna start by adding points in. I'm gonna go by my regular routine. Beach ball in a blanket, make it all weight, make it millimeters. All right, so in assembling all this, we want all the parts inside here. You could attempt to go through and do the stuff that's on page 104 or 105, but I'm going to do it the way that I like to do it. First, I want to start out with some axes. It's over here in reference geometry. And I'm going to use 2 planes. It'll recognize that's what we want to do if we open that up. And we go front plane and top plane. All right, so that's going to be the axes along which the piston moves. We'll do OK, and we'll make another one. Oh yeah, I have the so I'll get out of there and then just show you and do it again. I have by default, I have this little paper clip up there. Oh, and you can't see the axes because we need to turn them back on. So they're still there. It's still there. You just can't see it. Here's the front plane and the no, we don't want front plane. We want top plane and right plane right there. Okay, so we've made an axis right there. So let me go to view and display, no, view and modify, no, viewed, hide, show, there you go. View, hide, show, and axes, right? So now you can see the axes, right? So this will be, the crank will go about this, the piston will go back and forth onto that. So that's how I've set this up. So in assembly, we will go insert components, and I'm going to hit this the little pin to stick this in here. We'll put all the pieces in here. So we'll put in the conrod, put in the crank, put in the piston. Boom. Close out of that. All right, so one quirk of SolidWorks is when you pull something in, a lot of times the first piece that you pull in, it'll fix it, so we have to go to right click it. Oh, no, it didn't do it. There it is. Okay, so the first one we put in was this conrod, and you can see there's a float here. If I went over here, you can see this guy's, it says fix. So I can move him around, and I can move him around, but I can't move him around. So I need to move it around, so I hit float. All right, so now it can be moved around. So we will now proceed with putting in the mates. So we'll go to mate, and I like to make the things you use. I like to use the planes. So for the crank, we'll establish that front plane with the front plane of the assembly. So now we've made them, and they should be coincident. So click on the little check. Sometimes you have to do twice. I don't know why. Now the next, we're going to go and put him and make it coincident. So I'll hit that first with this axis. Boom. And I accepted it, and you could see now this thing has been stuck right there. We'll do the same thing for the front plane, and for the conrod, it's front plane. Right, so now it's going to be in that layer. Okay, so I had to click it twice for some reason. And now we'll do this, and it'll know to do a concentric. Boom, right there. All right, so now if you look around, what we have is we've made this thing so it works that way. A couple more. Let's go to the front plane, go to the piston, so pull down the piston one and make his front plane coincident. I think this is a much neater way to do this operation. And then last, we need to, just grab the outside of that, make it concentric with this, boom. Now this piston is constrained to go back and forth that way, and we'll make that concentric with S. Okay, so now what we have is this thing's fully constrained. All right, so the last constraint to make is one where we're just going to set it up so it's in the correct position in the beginning. We will suppress this constraint later. So we're going to go to top plane and go for the crank top plane, and now they're coincident, and we're done. All right, so now we have an assembly, and we should save it and go crank slider. Boom. And we are at the 18-minute mark. Now we need to go to SolidWorks Motion. But you go to the motion study. If you haven't set this up already, you'll only have animation and basic motion, but we need motion analysis, which you see I already have in there. That's because if you go up to this little gear, pull down this caret, and you see add-ins, and you'll see SolidWorks Motion. I already have it because I have this check mark. It already starts up with me. So you need SolidWorks Motion to be able to have all the access to the thing that we want to do. If we were to stick, okay, so all of that was the same thing as you would have up to through page 105. Now at page 106 is where they go to the SolidWorks Motion, and I have a note that says you must go to the add-ins to activate the SolidWorks Motion. And we're going to put a motor on. But first, we need to set up some other things. that they don't quite show. They go for 3 seconds. So let's stick with what they have. 3 seconds for them looks to be like they're going to have just one motion. I like to have 2 rotations. So here I would get different answers with what I would do. I think I would stick with the 20 RPM and 6 seconds usually gets me one full motion. So I'm going to stick with what I usually do, right? So, okay, we're going to pull this down with the motion analysis. I'm going to pull, one of the very first things I'm going to do is I'm going to right click, disable, playback, boom. I'm also going to get rid of that right there, that thing right there. Those features right there could be really annoying when you go back to look at the thing, because it'll control what the orientation of the view, and you would like to have that to be something that you can pick yourself. So I know that if we go right there to 6 seconds, now we can have 6 seconds worth of stuff. Also, one very first thing I should do, you could also see that, you know, these other things, they have all these constraints, but I want to get rid of that last constraint. The only reason I put it there is so that I could make sure I was started from a crank angle of 0. And I think I'm going to go counterclockwise to mix with this. So that's fine. Okay, so the next step is pretty easy. You just got to go to motor, and I like to touch on a round part onto there. And you can see I'm going clockwise for this, so I'm going to go here, reverse the direction. Boom. You can see my little red thing has changed, and I'm going 20 RPM. And I'm doing that just because it works out for the angles. I mean, it works out for the timing, right? That's all we really need to do. Hit a green check mark, and we have a thing. You can see the motor is right there, has been established. And I think I can just hit my calculate button. Something to note first, let's go to this gear. I think that we could go 60 frames per second, because in my, as you will see in my note, no, that's 120. So maybe I'll go 120. This we don't really have to worry about it. This will make 120 frames, so it'll calculate 120 things per second. And so essentially we'll be going, there'll be for every time step that you'll see, it'll go by degree. Like, so when you see the output, you'll see what I mean. 23 minutes into this, so let's go here, and then I'll just go that right there. So it'll calculate it, and it's gone around twice. All right, so now we actually have data we can show, and we could play this, by the way, and that's at single speed, so it doesn't look like massively fast. If you want to, you can go half speed. We can also, by the way, we can turn off those axes. We don't have to see them anymore. I'll mention that, like, anything that we do at this point, if we had those keys on, like if I went like halfway through here and then I made some change, it would think that you were like doing a movie script, and then that would change for the whole thing. So like, but we're not automatically creating them. So I'm going to hide these axes because there's no reason to see them. And if we want to make a movie out of this, you know, it's up to us how we orient the thing. You know, if you want to click on that, you know, by the way, you can always do that right there. You could click on it, but you can even go backwards right there if you want to. But you can also rotate the thing if you want. But I like to see it from this direction right here. We can have a nice little animation that we could create by saving animation. Don't make an AVI file, make an MP4. And then you can, if you hit save, it would make that. But a lot of times there'll be extra white space. So you might consider changing this right here, the aspect ratio. You can see that it's going to go off the screen. Unfortunately, you can't change this at this spot right here. You have to get out of this and then do it again to be able to see what these proportions are going to be. But before we make that movie, let's go ahead and get the results. So we take a result plot, and probably the one that we care about the most is going to be the velocity in the x direction. So we go velocity. We go up to here in the results. So I don't want to see the little thing goes x and y results and plots. And we'll go displacement, and then linear velocity, velocity in the x component. Now we have to pick a point. A lot of times I'll actually make a point on here, but I think it will accept this edge, will it? I might have to go back and put a point onto the piece. It'll have to recalculate the thing, but let's see. It creates a new plot. We can also put the vector onto there. Let's see if it accepts that. I might have to make a change because it might not like that circle as the point. No, it did. Okay, so here is the velocity for that point, and we can animate it. Boom. And you can see what the velocity looks like. It corresponds. It's got a nice little vector action going on. And you can see the little line. But more importantly than anything else, when we do this, is we go to this results and click here and right click and export to spreadsheet. And I make a note of that at the very end that you want to do this. And you'll see, you'll wait. Hopefully, if you do this on a computer a lab computer, it might not have Excel loaded up, but it came up to my other screen, but it returns this plot. This plot's awful. I hate that they make this plot default with those screen markers. But here's the thing that you care about. You could figure out at what time it reaches the angle, and then this will be the velocity in millimeters per second that corresponds to this. So it's hard to read that and know. I mean, you could just do the kinematics and find the thing out, but you can also, if you want to, we're about to make this a really cluttered graph, but it's kind of necessary for the output. So here's a couple other things to make this easier. We're at minute 27. I told you it could take a half hour to do this, right? I could show you how to do this in a half hour. You might want to go to position here, and now go to angular displacement, magnitude. Yes, fine. You often need a reference for this, so we want to get the angular displacement of this, and you might need a reference. Maybe we'll really take the reference for a top plane. No, it won't take it. So you might need to go up here and have two things and have a top plane. No, it won't select it. So anyway, I'm going to see if it gives me the thing I want, but I'm going to add it to this plot up here. And so when we get the output, we'll be able to see that. We don't need to have vectors showing onto this. Let's see if it'll allow me to do that. Yeah, so you can see that this is the angle that it goes through. There is another quirk. Okay, it worked out this way, but sometimes, and don't ask me why, this will be incorrect. So let me do one more thing before I demonstrate why I did that, and that is to add yet another thing onto the graph. If you wanted to do acceleration, go linear acceleration only in the x direction, and we'll go ahead and use that edge again. Once again, I'd rather have a point on my piston instead of that. We'll also add that to that same plot, and in this case put the vector in there, because now it makes it for an interesting looking video. And we go to this right here. Here is where this quirk happens. You see that? For whatever reason, you have to come down to expand this and do that. Right click on the velocity, the acceleration again, and edit the feature, and then just accept it. And you can see the numbers changed for what you'll get the wrong numbers. So this is the way to fix it. But you can see the green guy is the acceleration on that plot, and it's an interesting thing to see. Let me see. I'll shrink this plot over this to watch this now. It's a little bit more interesting. You can see this interaction between acceleration and velocity onto onto the piece. It's kind of neat. And now we can go to this plot and go export to spreadsheet. So it'll make another spreadsheet. It takes a second before it shows up, but it will just pop up. There you go, it's popped up. And now you can have all that. But so here is where this angular displacement that we wanted. And I just don't like having all these things as scientific notation because it'd be easier to see. You can see that we have increments of 1 degree. That well, it's actually 0.999999999. All right, so it's got a little bit of a quirk to it. But let's say that we wanted to get this thing when it was at 60 degrees, right there. And then here is the velocity, 163 millimeters per second. Here's the acceleration, negative 103 millimeters per second squared, right there. So we were actually able to get the exact numbers. That's the reason why we did picked the 20 RPM and picked the 120 frames per second, because now that combination will give us a degree per second. And so that's the way I've showed up to there. So lastly, in terms of presentation of this, I could do it from this. I could do it from the side, or maybe it would be more interesting in this case to do it from that direction right there. We could watch as this thing moves by, and we have to make a decision. Would we like this graph to be in our video? If we leave it up there, it'll be in our video, but it does a weird thing where it places it in a bad position. So I'll show you here where we make an MP4, because it's the smallest one. We'll pick a, I think the crank won't go out of the screen. We're wasting a little bit of this white space up and above. But anyway, we are, it's got a fine name, we're in the correct thing, so it'll resolve it here and make for a lovely exported video of 2 rotations. It takes a little time, gives you that fine little sound. And then, so if we go up to where I've kept my SolidWorks here, and it's right there, you can see it's made that video. Let's pull it up, and you can see there it's got the little, and it goes off the screen. So if we're going to be real good video makers, we should probably change the orientation, the size a little bit, so that we capture this. You can see that it has the graph. Do you want the graph on there? Maybe, maybe not. You could hide the angle one probably. So I would I'm a little more picky in the way that I present things. So first off, I'm just gonna I just moved it over to the side a little bit. I'm going to suppress okay, so it has the velocity and the acceleration, and you can kind of see their interplay as it goes there. And then you could do again with this. You have to go through again for the MP4 and change this aspect ratio, and then we'll right over the thing and wait a little bit at the end. That did it. And then hopefully it has updated this. Yes, so now we got rid of the angle because it didn't help us any. And we got the crank onto the screen. The vectors go off the screen, but we can't control that. So we have a really lovely video. And we also have the output of the actual values, numbers right there. And you can compare it to the problem that you will choose to represent the ICR when the thing is at the 60-degree position. All right. So one way to do that, well, you could superimpose this on, no, it's probably not worth it. The video is long enough at 35 minutes. Hopefully this will give you an idea of what you were supposed to do. You could use this. Of course, obviously I have used 20 RPM instead of the ridiculous 2000 RPM that they're using here. That would be a whole lot more, but you can get kind of an idea of what the velocity of the piston should be. They're using 40 degrees. I want to see if we should be like just proportional, right? I think because we've just been scaled. So what is our velocity at 40 degrees? We can come up to here. Looks like it's pretty close, right? I got a 128.5. 130 is what they had right up there. I didn't check this ahead of time as compared to 13, but of course we had to scale it by 100 and then also scale it by they're showing meters per second and we were doing millimeters per second. So you get the idea that we're in the ballpark. Not 100% sure why we're different. Some of this, a lot of times when it comes to doing this analysis, there's always a sort of a derivative thing that takes place, so that you could always be like one time step off because of the way the numerical taking the numerical derivative of something is a slope. So you have to decide if you want to get rid of the next data point, or it does. I'm sorry, I'm not making that very clear, but it is something that happens a lot of times. So you'll be one time step off from the one that you're looking at. So I've given you a lot of information. Maybe this will help you for your honors project or whatever it is that you're working on, because I might reuse this video for other people besides the intended audience of today. Goodbye.